We're going to go ahead and learn lesson 8.1, solving systems algebraically. Most of this is going to be a review for us. There is a part at the end that might be a little bit new. Let's just quickly talk about the different types of systems we can have. If it has a solution, whether it's from one solution to infinite solutions, it is called consistent. So if it has any type of solution, it's called consistent. If it has no solutions, it's called inconsistent. If, when solving, you come to a statement that's always false, like 0 equals 9 or -3 equals -10, there's no solution to that. And if you simplify a statement, it's always true, it's infinite amount of solutions, and it's actually the equations that you're given represent the same graph. So example 1 says use substitution to solve the system. Well, using substitution, there's not an easy one to solve for. So substitution obviously isn't the best here, but we're asked to use substitution. Let's go ahead and do that. So it looks like it will be easiest to solve for y. So in the second equation, so we'll subtract 7x from both sides, which gives us 2y equals -7x minus 11, and then we'll divide both sides by 2. And so we get y is equal to -7 halves x minus 11 halves. And then what we do, once we solve for one of the variables, we take what we solved and we plug it in for the variable in the other equation that we haven't used yet. So we will do 6x minus 5 times y. Well, we got y is -7 halves x minus 11 halves. And that is equal to -43. Not the greatest to work with, but it is doable. So we have 6x plus 35 halves x. So we're distributing here, plus 55 halves equals -43. If you want to get rid of fractions, you can multiply both sides by 2. You don't have to do that. You can continue going as is and solve, but let's go ahead and multiply everything by 2. So we have 12x plus 35x, because the 2, so we're distributing, would reduce plus 55 is equal to -86. And now we'll go ahead and subtract 55 from both sides. So on the right side, we get -144. Sorry, -141. On the left side, these become 0. We add our like terms together. 12x plus 35x is 47x. And we can now divide by 47. And x equals, I'm a little low in space here, x equals -3. And then what we do, we plug that back into either any of the ones, but we'll just plug it in right here. So we have, see if we can fit in here, y equals -7 halves times -3 minus 11 halves. This is 10 halves minus 11 halves. Sorry, not 10 halves. It's we're multiplying. So 21 halves minus 11 halves is 10 halves, which is 5. And so our solution is -3, 5. Now we're going to work on example 2. Example 2, it says use elimination to solve the systems of equations. Well, in order to use substitution, we want to have opposites or the same coefficient for one of the variables. It looks like it's probably going to be easiest to work with eliminating the y. So we have a -5 and a 2. So in order to get those to be the same, we'll go with getting it to be 10. So we'll multiply the top by 2. We will multiply the bottom equation by 5. And that gives us 12x minus 10y equals -86. and the bottom gives us 35x plus 10y equals negative 55. Now that we have that, we can go ahead and add them. It's going to go much quicker than substitution. So when we add those cancel, we get 47x equals negative 141. Divide both sides by 47, and you get x equals negative 3. Putting negative 3 back into one of our equations, let's just plug in the top one. 6 times negative 3 minus 5y equals negative 43. Just solving here. We will add 18 to both sides. Pretty basic stuff here. So this is going to be negative 25, and divide both sides by negative 5. And we get y equals 5. And so our solution is negative 3, negative 5, positive 5, which is good news because it was actually the same system as we did for substitution. Notice elimination was a bit easier in that case because we didn't have to work with fractions.